All right, we're going to go over the corrections for Chapter 3, Quiz 1. Started off, it says determine whether each equation is a linear equation. Write yes or no. If yes, then write the equation in standard form. So there's a couple of things you need to think about. Is it a linear equation? That's the first thing that you need to decide, which means is that equation going to yield a straight line? So some of the things that we know are not linear equations are when our variables have exponents other than 1. So if there's like an x squared or an x to the 4th power, anytime you have a power other than 1, it is not a linear equation. Anytime you have a square root or a cube root, so if you tried to undo a power, if you have the little radical sign anywhere in your equation with your variables, it is not a linear equation. Anytime you have two variables multiplied together, like x times y, it is not a linear equation. It's okay for x to be multiplied by a number like 2x, but you cannot have two variables multiplied together like x times y. And then the fourth thing you're looking for is to make sure that there's no variables in the denominator. So, as long as all of those categories are not met, then you have a linear equation. Once you have a linear equation, you can put it in standard form. Standard form is ax plus by equals c, where you have your x term first, your y term second, all on one side of the equation, and then you set it equal to your constant term that does not have any variables. Now, there are a couple of rules to this. A cannot be negative. Okay, so if my a is negative, the value that's attached to my x is negative, I have to do something to the entire problem to make sure that I can make that positive. I also cannot have fractions or decimals. Everything must be an integer. Okay, so your a, b, and c must be integers, which are whole value numbers. They could be positive, they could be negative, they could be 0, but they have to have a whole value. They can't have decimals or fractions. The only one that can't be negative is a. B, the value that's attached to your y, it can be negative. C, the number by itself, it can be negative. That's fine. The only one that can't be negative is a. But none of them can be fractions or decimals. And then the last thing is that their greatest common factor must be 1. Which means you can't simplify it down. So if you had a 2, a 6, and a 4, you could divide all of those by 2 so you can simplify that down. Okay, so now that we have an idea of what we're doing, we're going to apply it to these first 6 problems. The first thing is to determine whether it's linear or not. If it is linear, we're going to write it in standard form. If it's not linear, we're going to circle why it's not. So looking at number 1, I have x times y equals 6. Well, if I have two variables multiplied together, then no. This is not a linear equation because I have an x times a y. I cannot multiply two variables together. And so number 1 is done. Number 2, I have y equals 2 minus 3x. Are there any powers other than 1? No, that's fine. Are there any square root radical signs? No, those are fine. Do I have any variables multiplied by another variable? No. And then do I have any variables in my denominator? No. So yes, this is a linear equation. So once I find that it's a linear equation, I must turn it into standard form. So my problem is y equals 2 minus 3x. Well, I need the 3x on this side because I need x and y on the first side is equal to my whole number. So since I have a minus 3x right here, to get rid of it, I add 3x. If I do it to one side, I have to do it to the other. So that leaves me with 3x plus y is equal to 2. Ax plus by is equal to my constant. So I have it in standard form. Now I need to go through my checklist. Is a negative? No, so that's okay. Are there any fractions? No, that's okay. Are there anything that I can simplify all of these by? Can I divide all of them by the same numbers? I have a 3, a 1, and a 2. Well, since there's a 1, I know it's in its simplest form. So this is my standard form underneath it. I would say 3x plus y is equal to 2. So 2 parts on that question. All right, looking at number 3. I have to determine if it's linear or not. There's no powers other than 1, so we're okay. There's no radical signs, no square roots, so we're okay. I don't have x times y. I have 5 times x, I have 6 times y, I have 3 times x, but that's okay. And there's no x's in my denominator, so yes, this should give me a linear equation. Now I need to make sure that I get it in standard form. I have 5x plus 6y is equal to 3x plus 2. Well, I have x and y on my first side like I want, but I also have some x's over here. So I need to get rid of them over here to leave just the 2 by itself. So if I have 3x, to get rid of 3x, I'm going to subtract the 3x. But if I do it to one side, I have to do it to the other. And if I'm subtracting the 3x, I have to subtract it from something else that has an x. So I can subtract it here from my 5x. 5x minus 3x is 2x plus 6y is equal to 3x. I'm sorry. 3x minus 3x goes away, and it's equal to 2. Okay? So, I have it in standard form. ax plus by equals my constant. Now I need to go through my checklist. A cannot be negative. That's fine. There can't be any fractions or decimals. Well, all of these are whole valued numbers, so that's fine. The last one says the GCF must be 1. Well, I have a 2, a 6, and a 2. All of those are even numbers, so I can simplify this equation by dividing both sides by 2. When I do that, 2x divided by 2 is just x. 6y divided by 2 is just plus 3y. And then 2 divided by 2 is 1. So my final standard form in simplest form is x plus 3y equals 1. Okay, so there's your answers for 1, 2, and 3. Make sure that you have all your work shown 3 times for each of these problems to get the corrections on your, or the credit on your corrections. But we all know how that works. Moving on, numbers 4, 5, and 6. Number 4 says y equals 2x plus 5. There's no exponent greater than 1. I don't have a squared or a fourth power or anything like that, so I'm okay. There's no radical signs, so we're good. X times y, I don't have any variables multiplied by another variable, so that's fine. And I do not have any fractions, so I don't have any variables in my denominator. Fractions are okay, you just can't have the variables in your denominator. So looking at number 4, I'm going to say yes, that it is a linear equation. Now I have to turn it into standard form. I have y equals 2x plus 5. Well, I have my y on this side, but I have an x on the other side, so I'm going to move this 2x over. To get rid of 2x, I'm going to subtract 2x. If I do it to one side, I've got to do it to the other. Since there's no other x's over here, I'm just left with negative 2x plus y is equal to 5, because my 2x minus 2x goes away. So, it looks like standard form. X plus y equals my number. Now, go through your checklist. A cannot be negative. Well, my A is negative. So, what I'm going to do is I'm going to multiply everything through on this side by a negative 1. Because a negative times a negative becomes a positive. But remember, if I do it to this side, I have to do it to that side. So, ultimately, all I'm doing is changing the sign of this 2x. Since it's negative 2x, I want to change it to a positive 2x. But if I change the sign of one thing, I have to change the sign of everything. Because that happens by distributing my negative 1. So negative 1 times negative 2 is a positive 2x. But then negative 1 times that positive y is a minus y. Is equal to 5 times negative 1 is negative 5. So I can change the value of my or the sign of my first number, but I just have to make sure that I go through and change the sign of everything else. And mathematically, the reason that I can do that is by multiplying by a -1. So I still have it in ax plus by form. A is no longer negative. Next, I got to check for fractions. No fractions, so we're good. GCF must be 1. I have a 2, I have a 1, I have a 5. The common factor, the least common factor, or greatest common factor, I'm sorry, between those is a 1, so I cannot simplify it. So that is my final answer here. I don't have enough room to write it on here with the board, but 2x minus y equals -5 is the standard form for number 4. Okay? Looking at number 5. I have 1/2 y equals 3x plus 1. There's no powers other than 1. There's no radical signs. I do not have an x times a y. And then I do have a fraction, but my variable is outside of it. So if it was 1/2y, then it would not be a linear function. But since it's just 1/2 y, it's fine. So yes, this is a linear equation. Now I must turn it into standard form. So I have 1/2 y equals 3x plus 1. Well, I need to get this 3x back over on this side, so I'm going to subtract the 3x. If I do it to one side, I have to do it to the other. Okay? Since there's no other x's over here for me to subtract that from, it just becomes -3x plus 1/2 y is equal to 1. My first rule says a cannot be negative, so we're going to multiply everything through by a -1 to get rid of that negative sign. If I do it to one side, I do it to the other, and all that's going to do is change the sign of everything in that problem. So instead of being a -3x, it's going to be a positive 3x. But then that makes my plus 1/2 y a minus 1/2 y. And then it makes my positive 1 a -1. Okay? So now I have x plus y equals my constant number. No fractions. Everything must be an integer. Well, I have a fraction right here. So to get rid of this fraction, I'm going to multiply by its denominator. So I'm going to multiply by a 2. But if I do it to one thing, I have to do it to everything. So both sides are going to get multiplied by a 2. So 2 times 3x is 6x minus 2 times 1/2 is just that 1y. So instead of 1y, I'm just going to write it as minus y. Okay? And that's exactly what we were trying to do, was get rid of that fraction. So this 2 cancels out the 2 in the denominator, leaving me a minus 1y, which I can just write as minus y, is equal to -1 times 2 is -2. Okay? So now I have it in, I still have it in x, y number form. A isn't negative, so we're good with that. There's no fractions or decimals, so we're good with that. And the greatest common factor must be 1. So I don't have any number that I can simplify all of these by. So my standard form for number 5 is 6x minus y is equal to -2. Okay? And moving on to number 6, we have y is equal to 3 times x squared plus 1. Well, the first rule for linear equations says that there cannot be a power other than 1. So this is not a linear equation because I have x to the second power. So you say no, and you circle why that's not correct. Okay? So that's all of our questions on standard form. Then we moved on to graphing two lines by using the x and y intercept. If you remember, any number on the x-axis, any point on that x-axis, the y value is 0. For instance, right here is 2, 0. This is -4, 0. On all of your points on the y-axis, on all of the points on your x-axis, your y value is 0. Well, the same thing for your y-axis. Any point on the y-axis, x is 0. So in order to graph each equation by using the x and y intercept, you set x equal to 0 and you find the y-intercept, and then you set y equal to 0 and you can find the x-intercept. Plot those 2 points, and all you need to create a line is 2 points. So number 7, your work should look like this. I have x minus y equals 3. I'm going to take that problem and write it down twice. Here I'm going to say x is equal to 0. Here I'm going to say y is equal to 0. And then when I solve, I will get each of those intercepts. Okay, so x is equal to 0 means 0 minus y equals 3. Which means negative y is equal to 3 because 0 minus that 0 just goes away. Well, if negative y is equal to 3, I can divide both sides by a negative 1, and I get that y is equal to negative 3. Okay. Moving on over here, I have x minus y equals 3, same problem again, but now I'm just going to say y is 0. So x minus 0 equals 3. Well, x minus 0 is just x, so x is equal to 3. So once I've found each of my intercepts, I just go plot those 2 points. If x is equal to 3, on the x-axis, I go over to 3. 1, 2, 3, and draw my point. Y is equal to negative 3. So on my y-axis, I go down 1, 2, 3, draw my point, and then I just connect those 2 lines, those 2 points together with a line. So you must show me the work where you found each of these intercepts 3 times each. And then you must graph this 3 times each. If you need, go over to the table and get one of those papers that has the graphs on the front and back, so that way you don't have to draw this out. There's the assignment sheets over there that have the coordinate planes on the front and some coordinate planes on the back. You're more than welcome to use one of those. Okay? So number 8, we're going to do the same thing. We have 4x equals 2y plus 6. So we're going to go ahead and write that problem out twice. We're going to set x equal to 0 to find the y-intercept, and then we're going to set y equals to 0 to find the x-intercept. So it's going to look something like this. Number 8 is 4x is equal to 2y plus 6. Take that equation, write it down 2 times. 4x equals 2y plus 6. In one equation, I set x equal to 0. And the other equation, I set y equal to 0. You could do y first and then x. It doesn't matter as long as you do one of each. Because when x is 0, it tells you what y is. When y is 0, it tells you what x is. And so it'll show you where to set those up. So when x is 0, I would say 4 times 0 is equal to 2y plus 6. Well, 4 times 0 is 0 is equal to 2y plus 6. So I want to get this y by itself. So I need to get rid of a 2 and the plus 6. That 2 is attached to the y, so we're going to get rid of it later. So I'm going to subtract a 6. If I do it to one side, I have to do it to the other. So that gives me negative 6 is equal to 2y. 2y means 2 times y, so I'm going to divide both sides by 2. Negative 6 divided by 2 is negative 3. So negative 3 is equal to y. So my y-intercept for this graph is negative 3. Over here, I'm going to set y equal to 0. So I have 4x is equal to 2 times 0 plus 6. Well, that means 4x is equal to 6. I'm going to divide both sides by 4. And I get x is equal to 6 over 4, which simplifies down to 3 over 2. 3 over 2 is the same thing as 1 1/2. So when I go to graph these, my y-intercept is at negative 3. My x-intercept is at 3/2, so it's not going to cross perfectly in a corner. Instead, here's 1, here's 2. It's going to cross right there in between the 2 of those at 1 1/2. And then I just connect those 2 lines together. Okay. So that's how I can graph number 8 using my x and y intercepts. Plug in an x, find a 0 for x and find y. Plug in a 0 for y and find x, and then put those in their respective spots on your coordinate plane. Okay. Next, we're going to talk about finding zeros. If you remember, finding zeros is just a fancy word for your x-intercept. Where does it cross your x-axis? So, if you want to solve that algebraically, you do it just like we did right here, where you plug a 0 in for y, and it tells you what x is. You don't have to do this step because it doesn't care about your y-intercepts. It only cares about your x-intercepts, so make y 0. But they want you to do these by graphing. Okay? So I'm just going to graph each of these functions and determine where that function crosses the x-axis. So I have f of x is equal to negative 2x plus 2. Well, that's in y plus mx plus b form. So when I go to graph it, I'm going to start at my b, which is a +2. So I'm going to go right here. And then my slope is a -2, so that means it goes down 2 over 1. Okay, well that's where it crosses my x-axis, so I'm going to graph my line. It crosses my x-axis at 1, so my 0 is x is equal to 1. Okay, it's only finding your x-intercept. The zeros are the same thing as your x-intercept. Okay, next I have 1/2 x minus 2. Well, minus 2 is my b, so that's where I'm going to start, is at -2. My slope is 1/2, so when I do rise over run, I'm going to rise 1, run 2. So up 1, forward 2, up 1, forward 2. So I'm going to go up 1, forward 2, and that's my next spot. Up 1, forward 2, and that's my next spot. Now I've reached my x-axis, so I'm just going to plot those points, and I see that it crosses the x-axis where x is equal to 4. Okay, so that's solving by graphing. Number 11 asks us to solve it algebraically because I don't really want to go and graph something all the way down at -45 and rise 3, run 1, rise 3, run 1, rise 3, run 1, and keep going. So sometimes it's easier to solve it algebraically. When I want to know what x is, all I have to do is tell y to be 0. So I'm going to plug a 0 in here and solve for x. It's going to look something like this. Number 11. 0 is equal to 3x minus 45. Well, I'm going to add a 45 to both sides. So plus 45 plus 45. That gives me 45 is equal to 3x. Divide both sides by 3. 45 divided by 3 is 15. So x is equal to 15. That means that this graph right here, f of x is equal to 3x minus 45, will cross the x-axis. Its 0 will be at 15. Okay? And number 12 says the distance d in miles that a car travels in t hours at a rate of 58 miles per hour is given by the equation d is equal to 58t. So I'm given the equation. You don't even have to make it on this one. They were super nice to you. D is equal to 58t. It says, what is the best estimate of how far the car will travel? So what is the best estimate on the distance that it will travel if it was in 7 hours? 7 hours, 7 for t, t is time. So all you do is plug in a 7 for t. 58 times 7 is 406. So in 7 hours, you can assume that they will travel about 406 miles. Okay? So make sure you get those corrections done. They'll be due tomorrow. Corrections must be done on notebook paper, stapled to the back of your original assignment. You must write the problem down once, exactly how it looks here, so write it down how it looks, and then do the work and answer for each of them 3 times each for credit.